This is Andy Barrett of polyphys.com introducing an app depicting diffraction, or at least something like it. In the calculation, a bundle of rays leaves the source, reflects off of a rough surface, and then hits the detector. The size of the reflection surface can be adjusted. The frequency of the noise on the surface can be adjusted. This represents surface roughness, and this is one of the things I wanted to study in this app in addition to the geometric phase effects. And also the height of the roughness can be adjusted. Each ray leaving the source has a phase that oscillates over distance. The wavelength of this oscillation can be controlled, and also the positions of both source and detector, as well as their focal lengths, can also be adjusted. All of the rays are emitted with the same phase, but the phases may be different at the detector. I don't show the interference that would result from this, but on the right I do show two plots that help to understand what's happening to the phase. The top plot is a polar plot showing the amplitude phase pairs for each ray, and the bottom plot shows the impulse response function for the whole beam. Impulse response means that we send a narrow pulse into a system and measure how its shape is affected. It's a very common method for studying the vibronic properties of a system. So, a musical example of impulse response would be the sound an object makes when you tap it. When the source and detector planes are parallel, all of the rays reach the detector at the same time, and thus they have the same phase. This results in everything being lined up in both the amplitude phase plot and the impulse response plot. This scenario is ideal when you're trying to transmit information. Otherwise, when the phases are misaligned, the impulse response is smeared out and some self-interference will occur. Well, that's it for this app introduction. Go to polyphys.com to play with this app and many more. And if you like my work, then consider making a donation to keep this project growing.